Welcome back, Wild Kids. In this video, we'll be going over the solution to the problem that is shown on the screen. So let's go ahead and get to it. So the problem reads, the function g is a translation of the parent function f, 3 units to the right and 5 units down. What's the equation of g? And then they want us to write the equation in vertex form and in standard form. So I'm just going to go ahead and highlight a couple key points of information. So we know g is a translation of the parent function. So the parent function f, I know, has the following key features. So the parent function f has the equation f of x equals x squared with a vertex of 0, 0 and a stretch or an a value of 1. So they're telling us that g is a translation of this function that I just wrote and it's also pictured on our screen here. So since g is a translation, we just have to think about how it's translated. So they're telling us that it's translated 3 units to the right and 5 units down. So that would put our vertex of g at 3 comma -5, because this shows us 3 units to the right and this shows us 5 units down. So we're going to go ahead and plug that information into our structure for vertex form. So our structure, if you remember, is y equals a x minus h squared plus k. So I'm going to plug 3 and -5 in for h and k respectively. So I get y equals a x minus 3 squared minus 5. And since they're telling us that g is only a translation of the parent function, then it's going to have the same a value of 1. But we can go ahead and double check that because we can use this point 0, 4 or the y-intercept and plug 4 in for y, and we can plug in 0 in for x, and we can work backwards to solve for a. So if we're going to double check that, we get this so far, and then we're going to square that -3. So that becomes 4 equals, let's see, -3 squared. So that becomes 9a minus 5. Add 5 to both sides, and we get 9 equals 9a. So our a value is going to stay the same. So this is your vertex form for G. So I know that went a little fast, but I did that in the interest of time. So if you need to, you can pause, rewind, and rewatch as much as you need to. Okay, so we've written our vertex form for G, but we're not quite done because they also want us to write the equation in standard form. So let's take our original vertex form, and we're going to start off by expanding this part, the quantity of x minus 3. So x minus 3 squared is basically saying we're taking that thing called x minus 3 and multiplying it by itself twice. So I've written that out. Okay, the next thing we want to do is distribute the x and the -3 to the other x and -3. So that turns into x squared. X times -3 is -3x. -3 times x is -3x. And then -3 times -3 is +9. So I'm going to write that. And then don't forget to bring down that -5 all the way at the end there. Okay, so I'm going to go ahead and combine any like terms I see. So I'm going to combine these -3s, and I'm going to combine the +9 minus 5. So I'm going to combine these. So our final answer for standard form is y equals x squared. -3x minus 3x is -6x. And then 9 minus 5 is +4. So your standard form is y equals x squared minus 6x plus 4. Okay, and we know that we've done that correctly because we have a y-intercept of +4, and that also matches the y-intercept on our g function. And we can also double check the vertex. So if you look on the graph, the vertex is at 3 comma -5. All right, thanks for watching. Go ahead and try some of the other problems.